Flight controls. Objectives. After completing this section, you will get familiar with general information, ailerons, flaps, elevator, elevator trim, and rudder. General information. The Diamond DA40NG flight control system incorporates ailerons, flaps, rudder, elevator, and trim tabs installed on each of the elevator and the rudder. The flight controls are operated by control rods and cables. The elevator, ailerons, and wing flaps are operated by control rods. The rudder is controlled by cables, and the elevator trim tab is operated by a Bowden cable. Ailerons. The Diamond airplane has two control sticks, one for each pilot, that operate the ailerons and elevator controls. Ailerons have limited deflection angles, varying from 18 degrees to 22 degrees for upward deflection, while only 13 degrees to 15 degrees for downward deflection. Ailerons work in opposition. For example, as the control stick is moved to the right aileron is deflected upward, and the left aileron is deflected downward. Similarly, as the control stick is moved to the left aileron is deflected upward, and the right aileron is deflected downward. The ailerons are hinged flight control surfaces that are attached to the trailing edge of each wing, and are made of glass fiber reinforced plastic and carbon fiber reinforced plastic, composite sandwich material. Ailerons are used in pairs to control the airplane and roll, which is the movement around the airplane's longitudinal axis that causes changes in the flight path. The ailerons are moved by a system of push rods and bell cranks. Each aileron is connected to an aileron control horn, which is responsible for the deflection of the aileron's surface upwards and downwards. The ailerons are attached to the wings by a total of 8 hinges, or 4 hinges for each aileron. These hinges are comprised of hinge pins mounted in an aluminum bracket. Each hinge is secured in position by a roll pin. Note: the absence of the roll pin which secures the hinge in position can lead to the loss of the hinge pin and a consequent loss of flight safety. The operation of the ailerons is done with the help of ailerons control horns. The assembly of the ailerons control horns includes rod end bearings, steel push rods, jam nuts, screws, bolts, and nuts. The rod end bearing is screwed through a steel push rod and locked by a jam nut. A locking varnish is applied to the jam nut to indicate twisting. The aileron's control horn is connected to the rod end bearing by a bolt and a nut sealed with varnish, and it is attached to the aileron structure by 3 screws. Flaps. The referred airplane has retractable flaps for landing and takeoff. The flaps are mounted on the trailing edge of each wing. Flaps are high lift devices used to increase lift at relatively low speed, but they also generate more drag, so flaps are retracted when not needed. Extending the flaps reduces the takeoff and landing distances. Flaps are made of glass fiber reinforced plastic and carbon fiber reinforced plastic, composite sandwich material, and are driven by an electrical motor. The flap in each wing is a one-piece structure. The flap in the stub wing section deflects under the center part of the fuselage, while the rest of the flap deflects through the wing. The right and left flaps are attached by a fit connection and moved simultaneously to prevent asymmetrical deflection and retraction. The electrical flap drive includes an automatic circuit breaker, located in the essential bus section, which can also be operated manually by the pilot. The flap unit in the cockpit has a 3-position flap selector switch, and a flap position indicator. It is located on the lower right side of the instrument panel. The switch position corresponds to the deflection of flaps. The flap position indicator consists of 3 emitting diodes, each represents a different flap position. The flaps have 3 settings. Up, for cruise or ground, takeoff, and landing. The end positions have a protection mechanism that limits the switch movement and prevents overrunning. For cruise or ground position, the switch must be placed at the top. The top diode lights in green to indicate that the flaps are fully retracted, 0 degrees. For the takeoff position, the switch must be placed at the center. The middle diode lights in white to indicate that the flaps are partially deflected, 20 degrees. For the landing position, the switch must be moved to the bottom. The lower diode lights in white to indicate that the flaps are fully deflected, 42 degrees. Note: when 2 lights are illuminated simultaneously, the flaps are between the 2 indicated positions. This is the case only when the flaps are in the transition phase. Flaps are attached to the wings by a total of 12 hinges. 6 hinges for each flap per wing. A hinge is composed of a hinge pin, mounted in an aluminum bracket. Each hinge is secured in position by a roll pin. These hinges are used to attach the flap structure to the wing. Note: the absence of the roll pin which secures the hinge in position can lead to the loss of the hinge pin, and a consequent loss of flight safety. An aluminum fitting is positioned at the fuselage, and is attached to a torsion tube. This torsion tube is mounted inside the fuselage, and is connected to the transfer lever. The transfer lever is attached to the flap via 2 transfer pins. The torsion tube creates a connection between the right wing and left wing flaps. The flap control horn is connected to a rod end bearing, which is screwed into a steel push rod and locked by a bolt and a jam nut. The jam nut is covered by a locking varnish as a safety measurement to determine twist and apply adjustments. A total of 3 screws are used to attach the flap control horn to the bottom surface of the flap. When the flaps are completely retracted, the transfer lever and the flap horn are in a straight position. When the flaps are extended halfway in preparation for takeoff, the transfer lever and the flap horn are extended at an angle. When the flaps are fully extended for landing, the transfer lever and the flap horn reach their maximum extension angle. Elevator. The usual elevator control system is applied in the referred airplane. The elevator is attached to the T-tail horizontal stabilizer, used to control the airplane in pitch, which is the movement around the airplane's lateral axis. For example, as the control stick is moved to the rear position, the elevator deflects upwards, so the pitch angle is increased. Similarly, as the control stick is moved to the front position, the elevator deflects downwards, so the pitch angle is decreased. The elevator is made of glass fiber reinforced plastic sandwich material. It is installed on the horizontal stabilizer by means of 2 hinges and 2 end bearings with bonded bushes. An elevator horn controls the deflection of the elevator and creates a connection between the elevator and the horizontal stabilizer. The hinge assembly consists of a spherical bearing, bearing rib, and different assembly fittings. The elevator controls are divided into vertical installation and horizontal installation. For horizontal installation, a push rod connects the torque tube to the idler lever on the front main bulkhead. The idler lever is then connected to a bell crank. through 3 guide bearings, by a long push rod, to the elevator vertical control. For vertical installation, a bell crank attaches a long push rod, which comes from the horizontal elevator control, to the vertical push rod, in the vertical stabilizer. The vertical push rod connects the elevator horn, which is attached to the elevator's surface, with 2 screws. Note: both bell crank bearings are accessible to visual inspection, next to the lower hinge of the rudder. The connection to the push rod can be visually inspected, at the upper end of the rudder. A composite block is bonded to the inside of the upper skin of the horizontal stabilizer, and acts as a stopper to prevent the elevator from over-deflection. The elevator is in maximum upward deflection when the forward extension of the elevator horn is deflected fully upward and touches the stopper. The elevator is in maximum downward deflection when the forward extension of the elevator horn is deflected fully downward and touches the stopper. Elevator trim. The elevator of the airplane is designed with a trim tab. It is operated mechanically, by a Bowden cable. The trim tab is used by the pilot to balance the elevator forces that act on the elevator. This results in the reduction of the manual energy and work required to stabilize the airplane during flight. The trim tab can rotate around the pivot axis, however, this rotation is limited. The trim control is a black wheel, located in the center console to the rear of the throttle lever, in the cockpit. It has a friction device that prevents the wheel from over-rotating. The takeoff position is clearly marked on the wheel. Changing the setting of the elevator trim tab adjusts the neutral position of the elevator. Turning the wheel to the rear towards the nose-up position causes the airplane to trim upwards, thus increase pitch angle. Similarly, turning the wheel to the front towards the nose-down position causes the airplane to trim downwards, thus decrease pitch angle. The elevator trim tab is made of composite material and consists of 6 hinges, a trim tab horn, 2 hinge rods, and lock wires. The hinges are used to connect the trim tab to the elevator structure. The 2 hinge rods pass through 3 hinges each and are held in place by lock wires. Rudder. The rudder control system has the following parts: 2 sets of rudder pedals, 2 adjuster handles, and 2 optional adjuster switches. These parts are located in the cockpit, one for each pilot. The system also includes a yoke assembly, also known as T-shaped lever assembly, located in the fuselage below the center console, a rudder pedestal, located at the rear of the fuselage, and cable assemblies. The rudder provides a yaw flight control, which is the movement around the airplane's vertical axis, using a rudder pedal assembly. The rudder has a fixed trim tab that provides trimming of the rudder for better yaw control of the airplane. Each rudder pedal moves in the opposite direction. When the right rudder pedal moves forward, the rudder moves to the right and pulls the left pedal aft. When the left pedal is pushed forward, the rudder moves to the left and pulls the right pedal aft. The rudder is made of glass fiber reinforced plastic sandwich material and is assembled to the vertical stabilizer by 2 hinges, upper hinge and lower hinge. The upper hinge attaches the rudder to the upper section of the vertical stabilizer by 1 bolt. The lower hinge consists of a bearing bracket equipped with a rudder stopper, which is screwed to the rear web of the vertical stabilizer by 4 screws. The bearing bracket is attached to the rudder by 2 bolts. Note: the bolts and nuts used to attach the rudder to the vertical stabilizer are accessible to visual inspection. For pedal adjustment, a black handle is used to adjust the pedals. It is located on the aft face of the rudder pedal assembly. Forward adjustment requires keeping the handle pulled, while pushing the pedals forward to the desired position. Releasing the handle allows the pedals to lock in position. Rearward adjustment requires keeping the handle pulled, while pulling the pedals back to the desired position. Releasing the handle and pushing the pedals forward will lock them in place. Note: pedals may only be adjusted on the ground. Pedals are connected to the rudder via control cables. The control cables go through Teflon tubes all the way to the control bulkhead. The control cables are divided into two sets of cables, outboard and inboard cables. The outboard cables connect the outer pedals to the control bulkhead through two guide pulleys. Similarly, the inboard cables connect the inner pedals to the side arms of the yoke. The two control cables attached to the rear of the yoke are connected to the rudder lower mounting bracket, where they cross over each other in the rear fuselage. Note: an electrical pedal adjustment can be provided in the DA-40NG airplane as optional equipment. Two positioning switches, one for each pilot, are located on the left and right hand sides, at the rear wall of the legroom. The positioning switch causes the rudder pedals on the corresponding side to move along the guide rail. Summary: with this section, you got familiar with general information, ailerons, flaps, elevator, elevator trim, and rudder.